Hello everyone. So today we organize a webinar with Syscom. So Bart will be there to help me to present the product, and I will present more like the how to configure and interface with the Syscom device with T4D. We're gonna talk about automatic vibration monitoring using the Syscom device, and it's our first webinar for February. Okay, so maybe you can introduce yourself, Bart, first.
Sure. Thanks, Ben. So I'm Bart Jaco. I'm working at Syscom since now 7 years. I'm in charge of the business development, sales and marketing. And yes, we are manufacturers of vibration monitoring devices. And I'm glad that we are able to present this webinar with Ben and Trimble, and having the chance to interface the devices with the T4D platform. And we'll show you how this works later on in this presentation. Obviously, I'm available with my email if you have any questions, and you can also forward all the, your comments and again questions to Ben as well.
Yeah, and so I think most of the people here knows me, but my name is Ben. I'm technical product manager with Trimble, and I work on monitoring business for more than 7 years. And I have I have like my experience is more about like survey equipment, but I also installed geotech and vibration sensor when I was working on site in my past career. If you have any question, you can also reach out to my address email. You can see in the presentation, or just to repeat, Bart email address with syscominstrument.com. So we divide the presentation in 4 different parts. We will start by a quick introduction about Syscom. Then we will talk about vibration monitoring in general. Then I will show you how to setting up, or Bart and I will show you how to setting up a Syscom sensor with a web UI. And then we will talk about the deliverable on T4D, how to configure, display, and report the data. And then we will finish by a quick exchange with you. So it's your part.
Yes, thanks, Ben. So also, if you have any questions, you can put them on the chat, and we'll try to answer during the presentation. So Syscom Instrument, we like to say that we are leading supplier of vibration monitoring solutions. And next slide, Ben. And so we are based in Switzerland and now part of Terra Insights Group. So Terra Insights is a group of companies that includes RST, geotechnical instrumentation, measurement shape arrays, and 3VG for INSAR technologies. Syscom vibration devices are made in Switzerland, and you see a view from our office there, Swiss-made products. And what is the, let's say, the DNA of the devices is to provide real-time vibration monitoring. And to do that, we need obviously a built-in 4G modem. So this is what we install in all our devices. That makes a lot of sense, to bring let's say state-of-the-art vibration monitoring to our customers. And we are targeting a few different markets, and one of these is safety industries, nuclear industries, LNG industries. And based on the processes we had to put in place for these industries, we used that to manufacture all the equipments. And that's the reason why the vision of Syscom is to provide the most reliable and devices and affordable devices to our customers. And we try to remove the pain by doing the vibration, especially again with remote monitoring. Next slide, Ben. So what are the typical applications for vibration monitoring? And there are 3 main, I would say, applications. And first is compliance. What we see when you measure vibrations, usually you measure peak particle velocities with a geophone sensor, and this is highly regulated in I would say, most of the countries in the world. And I listed a few standards there, the RA 8507 and maybe the DIN 4150, which is probably one of the widely used standards, specifying structural vibrations limits depending of the applications. And usually it's depending of the type of buildings, if it's an industrial building, you know, a residential building, and so on. One other aspect of this compliance is the human comfort applications, and more we see on the market that let's say customers are looking to measure human comfort with in this case sort of a vibration dose values aspect. So meaning that, for example, you are allowed to you know, generate vibrations during a certain period of time during the day for 6-8 hours, depending of the level of vibrations, and then you have to stop your work. So the devices that we provide can really give you a true input for these kind of things. Then the second one is structural, and for structural, it's really like related to SHM. So obviously to liabilities, who is responsible to the damage of the structure. And by analyzing the vibrations and monitoring the vibrations, you can define if there were too high vibrations level or not. And maybe with that structural SHM applications, you also have some, I would say, modal analysis, and to understand how the structure moves and have some, you know, different shapes, modal shapes, to understand if your design models are respected and are compliant or not, and if the structure was properly built or not. And with that, you can use ambient vibration monitoring. And another thing is earthquakes. So when you have an earthquake, you can measure and monitor the structure to understand how it moves and make sure that it's safe and it will sustain the next earthquakes. Last one is safety, not really related to, I would say, T4D, because in nuclear industries, you don't want to, you know, push the data over internet and so on. So that's also another application, but less of concern for Trimble and T4D applications, which is really, I would say, limited to compliance and structural monitoring.
But with T4D, Bart, we don't obviously we don't need to send all the data on a cloud. We also have like it's an on-premise application, so you can install on a local computer. So maybe I think it could be used in nuclear.
Sure. I think, yeah. Next slide, Ben, please.
So yeah, you want to present this one?
Yeah. So how does this work, and what's the purpose of vibrations in the end? Most of the time, you don't have, you know, too high vibrations that are interesting. So you don't want to you know, just save gigabytes of data and then take days to analyze the data. So usually it's trigger based, and when it is trigger based, this is the line that you see here on the graph. When it is written no events, it means that there are no trigger amplitude that is exceeded, and basically the system is not recording any data. And then when you have an event, it means that when the trigger is exceeded, you will have a high sampling rate of the signal, maybe 1000 Hertz or up to 4000 Hertz. And this will, in fact, record the dynamic signal of vibration. And with this dynamic signal, you can really analyze deeply what's happening with typically the amplitude, the time history signal. And also what is very important is to have the frequency bandwidth that is related to the recorded signal. So that's the two things you analyze usually: the amplitudes with the time history and the frequencies related to the recorded signal. Next. So that's what I mentioned. Here you see the blue curve. It's a typical vibration signal on one axis. You can see the damping. You see the damping of the signal to try to, you know, reduce the amplitude of the vibrations. And we're talking about pre-event, event, and post-event time to capture the entire event. having the trigger, level really allows to avoid processing all the data and spending time for unreally uninteresting signals, and you will save a lot of time when you evaluate the recordings. Usually you can measure up to 100 millimeters per second, but the rule of thumb, I would say, is that 0.2 millimeters per second would be something that humans can start feeling. 2 millimeters per second would be already a quite high vibration, and you will really feel disturbed by that. And above 20 millimeters per second, typically there will be heavy damage to the building. So that's a little bit the amplitudes we are looking at. And like I mentioned before, when nothing is happening, when you are not, exceeding the trigger level, you will not have any recordings. So what's interesting in this case is to have a background continuous recording. Some people are referring as an histogram to that, and it's typically a record of a period of one measure every minute, for example. So you will get one point every minute continuously during the 2, 3, 4 months, 1 year duration of the project. And with that, you have two benefits. First, you see that the system is operating properly because you get data on T4D platform. And second, you see that the trigger level was not exceeded, meaning that everything is fine on your monitoring site, and you can rest peacefully. So in the end, what is interesting to get, apart from having the dynamic signal, the background signal, is to have some alarmings and notifications, because basically this is what gives you relevant insights then to take actions. So having frequency and amplitude-based alarmings. So frequencies are on the x-axis in this case, and amplitudes on the vertical axis, allows you to easily detect if the green points here are above or below the line. And if they are below, meaning that you haven't exceeded this specific standard, it's a US-based standard, meaning that you are fully compliant to the regulation. And if you exceed these lines, then probably that you will receive an email or an SMS as a warning, and you will have maybe to do things on the construction sites, for example, or on your monitoring project to try to avoid this kind of exceedance. We are manufacturing two types of instruments at Syscom. First one is MR3003C. That's one of the best-selling items. MR is a motion recorder. In fact, it's yeah, thanks, Ben. In fact, it's a data logger with an internal sensor, 3-axial sensor, and a built-in modem. And so with this compact device, you can push the data directly to your platform or to the T4D platform. And it's very easy to use, a very versatile product, because you have an embedded web user interface, meaning that you can connect with your mobile phone or whatever computer to the device directly, and you can set up the system very easily. Really the main thing with that is to be able to communicate remotely to the device, so remote monitoring, real time, and for permanent monitoring. Next. And the other category is the ROC devices. So in the end, it's also recording vibrations, exactly the same. Geophone-based velocities measurements, 3-axial sensors, but this one integrates a battery and is really super low power. Compared to the others, you have an internal battery and up to 6 to 8 months autonomy without cables, just with the battery. What is important, you can also put a small solar panel. It's what we see on the top right corner, and that will maybe bring 2 to 3 years autonomy if you have direct sunlight on the device. And basically, it's a very easy to use device. You have one button, you put it on site, turn it on, and then you get the data directly on T4D and to evaluate what's happening on your site. So that would be a very best-in-class device for let's say, standardized applications, compliance solutions, and it's really providing a great handling and efficiency in your monitoring, because it's easy to use, easy to install, and so on. So the big difference with the two is which one to choose basically for what applications. So when we look at the MR3003C, the one on the left, it's a sales business model. So basically you buy it and then you do whatever you want with it. It's normally for long-term usage. I mean, the lifespan of a device like that is more than 10 years probably. It's very versatile. You can measure a lot of different things, from blasting to piling to very low amplitudes for MRI monitoring or things like that. I would say it's more for more specialized, let's say, people that will make the most out of it. And it could be a standalone device pushing the data directly to the T4D platform or to whatever platform you would like to use. Maybe an FTP server that you are hosting by yourself, because sometimes you have some constraints on where the data are going. For the ROC, it's more on a rental business model, and based on the 6 to 8 months, autonomy that it's providing, then it's very much suitable for projects that are lasting up to 6 months, because then you're saving a lot of money without, laying down cables and things like that. It's really suitable for standard, typical compliance solutions and easy to use. And on this one, the ROC must push the data to the SCS. It's a Syscom cloud software. Basically, it's a platform which will then forward the data to the T4D platform. And using that, you will be able to manage your reporting and notifications through the T4D platform. But this one must go through the SCS and the T4D platform. You cannot use it as a standalone or directly with your own software solutions. And when you have a need of 10 or more devices for these ROC devices, then you should contact Ben or myself, and we'll find a suitable agreement to do this monitoring.
Okay, so I think this is still your part. Mm-hmm. So I think you're gonna introduce a different user case.
Yes, there are a few examples here to give you some, monitoring ideas, I would say. I'll go through that quite quickly. Here, this was a project in Portugal, I think, with 3 devices. They were building a tunnel for water irrigation. So they had to monitor the tunnel, the bridge. And you see here 3 devices on the pillar, on the table of the bridge, and on the, let's say, basement of the bridge, linked to a solar panel and some backup batteries. So that was an example of a monitoring. Okay. They have an NP2074 in Portugal. That's a standard that was used. Here is I think in Zurich train station. The red layout is the construction site, and they had to make sure that the existing tracks and the existing buildings are not damaged. So they put 4 measuring points there for, I think it was like 6 to 9 months. And you have examples on the right how it was installed in buildings and near the train tracks. Another example for blasting monitoring, you have an existing tunnel on the left. You see the 3 red dots, that are 3 devices, and they wanted to blast a new access tunnel, the one that you see basically vertically. And they had to protect a few walls, very like middle-age walls, sort of ruins that are protected. So that was a little bit sensitive. And also the existing tunnel on the right, just to make sure, that by blasting, you won't have rocks that are falling down to the, gallery that is already in place. And when you look at the bottom right, that's typical signals you get, time history signals, 3-axial, when you are measuring and monitoring blast vibrations. Last example with some ROC devices here. So they were like soil improvement techniques with piling, and they wanted to put like sheet curtains to protect the rail tracks and so on. So here there were like 2, 6, 7 devices for a couple of months, and you see the ROC devices without cables. In this case, very convenient because you have the tracks, and obviously you cannot put really cables, below or over the tracks for obvious reasons. more for structural monitoring. Here you have the dam with on the left upstream, downstream on the right, with 3 devices that are permanently installed on the concrete pedestal that you see here on the right. And this is protected and supposed to last 15-20 years to monitor how the dam behaves. Here it's a project in Bulgaria, I think. And last example, I think, is a bridge monitoring in Greece. In this case, they put these sensors that you see on the right, and the power options here was interesting because it was PoE, so you can connect these devices using PoE, meaning that you have only one cable to get Ethernet communication for remote access and also the powering options, and then you push the data to any type of platforms. Could be T4D in this case, with several sensors that are, plugged in one software solution. Thanks, Ben.
Okay, so maybe we have we have like a few questions. We can pick some. I started to answer. So basically, there is a question about the 4G communication. They ask if the 4G is the only communication you can have, but I think you already answer. You can communicate with Ethernet, but we also have like this device also have an embedded Wi-Fi access point, so you can connect. For example, if you are in a tunnel and you don't have access to any network, you can connect with your phone to this device, and you can configure it using your phone.
That's for the MR3000. That is correct.
For the
yes.
MR3000. For the ROC, I think is kind of different. The ROC is directly connected to the platform SCS, which is a cloud-based solution. So basically, it's just one button you turn on, and automatically you just have to add your sensor in a cloud platform. So you always need internet, Wi-Fi, 4G in this case, with a
Yes.
I think we have another question about do you have the availability to measure vertical displacement with an accelerometer during an event?
So not directly. These devices, the MR3000 can have a velocity sensor or also an acceleration sensors in some configurations. Usually it's velocity, I would say. And then you can, as a post-processing, you can obviously integrate the signal to get displacements and then analyze the displacements. But it's not a direct measurement of displacement. It would be first velocities, and processing the signal would allow you to get access to displacement.
So after, there is another question about, it has been mentioned that MR3003C is a data logger with 3 axial sensor, but is it possible to connect some additional vibration sensor?
No, not on this one. It's only 3 channels. We have another one device that is specifically designed for blast applications where sometimes you need air pressures. So in this case, you will have a 4th channel, but that is limited by 3 channels. The idea behind that is to have like a distributed network. So meaning each point in your network will be standalone. So if you don't have any communications for whatever reasons, you will still monitor individually the things. So I would say it gives redundancy in your monitoring, probably quite interesting in terms of reliability at some point.
And after, like, Jörg asked a question, but I think you already answered if SCS is a subscription. So yes, it is. And about the cost, I think, Jörg, it would be better if you reach out directly to Bart after the meeting, and I think you can discuss about it.
Manual processing with the SCS is entirely free, but when you want automated processing and things like that, there is a subscription. Normally, it's not that expensive, I would say, but okay. You can send me an email and I'll explain you the details.
Yeah. And I think it was a good question also about the battery on the, I think 6 months is on the ROC. So what's happened after 6 months? Is it possible to recharge after the device after 6 months?
Yes, it's a rechargeable battery. Charging the ROC takes about 1 day. So when you have a longer project, I would say the idea is to go to site and swap the device with a new one that is fully charged. Otherwise, take it out for a day and charge it then.
Yeah. Of course, is when you don't have access, when the device is not installed outside, because if it's installed outside, you still have like the opportunity to install the rack with the solar panel integrated,
Correct.
as Bart mentioned. So let's start about setting up a sensor. So today, I just want to integrate, first of all, the two different workflows, the one with the rack and the one with the MR3 3003C. So about the rack, there is a SES platform. So it's a cloud-based platform. And basically, you just turn on the device and automatically you just add the serial number on the SES platform and you will be able to see your device and connect. Then to communicate with T4D, so this is an important point. You need to install a SFTP server. Obviously, it has to be like in a different computer. So basically you can have like a computer at the office and you host your SFTP server. And this data will do a buffer between your T4D control server and the SES platform. We have to do this for cybersecurity reason, to make sure, there is no one sending like a virus or whatever directly on the T4D control server. So basically this SFTP server just collects the data and T4D connect on it and get your data. About the MR3003C, it's a little bit different. So you have a web UI on the device and you can do like port forwarding to connect, or you can connect remotely using VPN or fixed IP SIM card. And then like you can transfer the data directly to the STP server onto like the IP of your server, and then it will transfer the data here. For this, you don't need any fixed IP on the device itself. And after, like T4D in the same way will collect the data and will display, report and analyze your data. Okay, so about the different platform. So there is the MR3000C, so it's a web UI directly hosted on a device. So here it's a screenshot of how we configure. So basically you go on system and FTP send, you select SFTP as I mentioned, and you will have to enter your username and your password of your SFTP you configure. And then you will send automatically the data. So what is very specific with Syscom device, as Bart mentioned, is the device itself who will trigger the alarm. So basically you configure on the device what is the level of vibration you want to alarm, and then the device will, when it will detect a vibration, it will send a file, it will create a file on your folder architecture directly on your SFTP server and on the device itself. About the rack, it's you have to connect on a website. So there is a connection, a web connection to the cloud service. And then you can just directly select your rack, and you just have to enter in the same way the Trimble SFTP. And you enter your username and password and your pass, and after all the data from all your rack installed on site will be sent directly on your SFTP. So maybe I can just share like the web interface of my Syscom here. So this is the device I present to you here. I just move it a little bit so you will have a lot of alarm to see on T4D later on. Basically, this is here, and you have the SFTP, the FTP, and then you can send to from the Syscom to your SFTP. About the alarm, you can manage your alarm, and then like directly here you can also see on the device itself all the alarm has been sent. I just want to show you on the, so here I connected on my SFTP directly, and I can show you like the different data created. So basically there is two folders, one for the background when there is no alarm, so it sends regularly the data, and another one for the event. So here I didn't have event yet on this device, but you have a second folder for the event, and then you will have the event file, and it will plot in a different way on T4D. Okay. So I think for now it's kind of clear. About T4D. So first of all, I want to introduce why we integrate vibration on Trimble on T4D control version 6.3. So we integrate vibration. I think is part of the work we do with the monitoring team to be as much as we can agnostic and support as many sensors as we can on the solution. And for this, we decide to add like a different analysis to have like a global solution and to be able to analyze globally your project. For this, we create a different view. For example, here in the side, it's a custom view. So you are able to put like images or a video webcam, and then you can plot directly on a view your image. We also have a GIS view. So you can see with the background, like, for example, I will show you it's a Google map or other provider background, and you will be able to see all your sensor, different type, geodetic, geotechnical, and vibration. And then you will be able to report and alarm all the data on one platform. Again, all these features are available on the version 6.3 of T4D, and you can I will give you access. If you reach out to me later on, I can give you access to my demo system and you will be able to see. So first of all, if you don't have the opportunity yet, we make a video about like how to set up your SFTP server. So you can reach out on our YouTube channel and you will see how to set up your SFTP server. Just to understand, SFTP is like a cloud service. So basically with one SFTP, you can connect as many as you want device. So it's not just one device, it could be 100, 500 here. Okay. So, okay. About the vibration, I think so how to configure. So then I show you my presentation. So here we are on T4D, and the benefit of vibration is the same workflows and what we have currently for geotechnical. So everything is configurable through the web. You don't need to enter on a server side. So you have to go on the administration and you select your project. So for now, I have only one project, Trimble Nantes, but today, before in 6.2, you had only Geotech Gateway, and now we add a new gateway, is a vibration gateway. So you have two different, you have a listing on new gateway. Here we want to add a new gateway. For now, we only have Syscom provider. I'm gonna create Trimble Nantes webinar. And my gateway is this one, trimblemonitoring.dns.org. And you have to enter your port. So protocol, you don't have choice, is SFTP. And then you enter your login and password of your gateway. Then you have like root on your SFTP server. You have a name. For example, here I just create the name of the device. And here, and then you have to enter the name of the device here. So the name of the folder of the path. So here is a serial number of my vibration sensor, and if you save, automatically it will save the device. Then it's very easy. So here is a name, Trimble vibration webinar. So it's a name you will have on T4D. And after you can enter the coordinate manually, or you can like use, for example, the survey you did with your GNSS. Here I won't enter any coordinate, so it will be 0, 0, 0. And then, as you know, you select the sensor you want to add, you click on the green button, and automatically it will import all the data from your server to T4D. And here, if it's a green light, so sensor Trimble vibration webinar is added. So then I can come back on the web interface of T4D, and if I go on my map, I will be able to see my device. Of course, here I didn't add any coordinates, so this is why like the sensor is far away. But here you have the data, so we have to wait for a few minutes, just the time the data are imported. So I already have another sensor to show you. I create a custom view, so it's also the opportunity for me to show you this. Okay, so here you can select your custom view. So I take a picture of my sensor earlier today, and after you can add like the background as I show you of your device with a view. Yeah, I'm sorry, it's kind of long because I think I'm importing the data in the same time, so my server slowed down. And then you are able to visualize your data, and you can see the alarm I got today. So all the triangle here is events my vibration sensor detects. And so as you can see, you can define like a different type of visualization. So you can have like last event, you can plot the last event, or you can just plot the graph as I show you. So here I decide to plot the graph, but you can also plot each event. I can come back on the event if we really want to analyze the events of the vibration sensor itself here. So as you can see, there is a lot of event because I move the device a lot and it's on my desk, so it worked well. So here is a detail of the event. And if you select, so here there is all the event from all the sensor I added. And if you select one event, it will give you the time, how long what is the event duration. And then here, this is what Bart explained to you. Here is a high frequency measurement from the device, the 4000 Hertz. And you're able to see like in a very accurate way and very high frequency way, the vibration of the device. So between here and here is 1 second. So we are measuring 4000 Hertz. If you want, you can plot in the same graph like the event and also the background. So I just need to find vibration. And so here, if I select this sensor, so here I plot the background and the events. So in green, black, and blue, it's the background. I can remove all the events. So this is the background here in X, Y, Z. This is the velocity, the speed, and R, and the velocity R in a background. So it's measured every 15 minutes, I think, or every hour. We have one position every hour in this case. And after, like if I remove this, you can just plot just the event. So this is the event when the device raise an alarm. And after, like if you want, you can select your event, you can click on it, and automatically you will have the graph. So there is different way, as I show you, to visualize an event. So you can select directly the chart, or you can go directly on vibration events, and then you will see all the central events. So here is the sensor, here is the time, and after you have different information like the duration. For example, here it was like an event duration only 7 seconds, 10 seconds, and here is a velocity. So basically we detect the alarm based on a peak. So when it exceeds a certain peak, you raise an alarm. Okay, and we make a composite view to be able to see our vibration sensor, and also to be able to visualize in the same graph all the events. So here you can see your sensor, and I added the sensor, but you can just put an image. And if you want, for example, like this is used basically in a control center. So they plug this, and if they have alarm, they are able to check directly and select it and be able to visualize the event. And here you can select and zoom in and out and select the time you want to display. Okay, I don't know if there is any question for now. No. Okay, about the alarm. So here we create different level of alarm. On the alarm, you can also raise alarm on T4D if you want. So basically the sensor itself, because it measures very high frequency, so T4D cannot send like when it detects the vibration, we want the sensor itself raise the alarm on this own, because it's the sensor is in a rush to take measurement. So this is why the sensor itself has to manage the alarm, but we also have like a way on T4D to manage the alarm. So for example, when you raise an event with the sensor itself, you're able to receive an email, or the customer will be able to receive an email also. So here we put different level of alarm on different component on X, Y, or Z. And also you can create an alarm if you don't have data for hours or days. About the reporting, so we also have an option to make reporting. So as I mentioned at the beginning, this is also one of the strengths of T4D. So you can make a different analysis type. For example, here I can select my data from my SX12, for my S9, for my GNSS, but I can also now add my vibration alarming. So I can, in one report, you will have all your sensor. And if you want, for example, if you want to have like a separate report, you're able to plot just a chart of the vibration. And here, this is a report we make. So on T4D, everything is possible to configure everything. So if you want, you are even able to change and customize your logo. And yeah, this is basically the report I receive every week with a sensor, and or like here it was with the old sensor, so this is why I don't have data. Or it's with you have the peak and the velocity and the background and also the event. Coming back to here to the vibration, if you want, for example, if you have an expert to vibration of the vibration on site, you can also manage in a report the different people who receive the analysis. So for example, if you go on analysis, here I just put my name, but if I want, I can put like different team member, for example, Riley, and Riley will also receive daily report for vibration. So coming back to my presentation so here also maybe I can, coming back to the presentation, so you can select on the event the different time you want to select the event triggered. And then for the reporting, you can select the person and the schedule and the analysis view and the different analysis if you want to put all the device, all the data you collect from different sensor or just the vibration. So I think for the demonstration, it's almost it's done. So I don't know, maybe we can spend some time with you to exchange about if someone has a question, or maybe it was clear. Okay, we have very interesting. Okay, so it's good. It seems like there is a lot of interest, as I can see. Thank you, Elch. I don't know if you have question on how to display, or maybe not really. Bart, do you want to add something?
No, thanks for showing us that, Ben. It was very good. I think that T4D is a great platform, to integrate several type of data. So not only vibration, but also your other type of Trimble sensors, and that's a great addition to also the vibration offering that we are doing here.
Yeah, maybe what I can add is like showing to you the sensors, the Syscom. So basically for the MR3000C, this is a device I have here. You have the device and you also have a battery pack if you want. And you can connect external power and then the battery will power your device. So it prevents the power outage, for example, on site. And this battery is able to power your device when there is a power outage. How long, Bart?
It will be about 4 days with
4
this
days.
MR3003, yeah, up to 4 days.
So maybe like we can just remind you like the different high topic for vibration. So we integrate two different devices. One is a MR3000C. So this device is more like a selling business model. So basically, if you want for a project and it's more, I would say, a long term for many years, maybe the MR3000C is better. And if you want like a short-term project and in an autonomous way, for example, if you need to install for 6 months and you don't have external power around, maybe the rack is better. For the rack is more like a subscription, and you will have to connect your rack through SES platform, and the MR 3000C, 3003C. It will be you don't need subscription if you work with the SFTP workflow.
Correct.
For now, we T4D support speed, but it depends on the customer, I will say. But maybe soon we will support the acceleration. So yeah, I think so. Yeah, I don't know if you have more question. Is it possible to obtain test unit? I think yes. Maybe we can discuss about this with Bart. So Matthias, if you want to contact Bart, I think we can reshare maybe his email address. Can I join your project, Zasulan? Yes, of course I can create an account for you and adding you. I think the other question we already about the alarm. Can we set up an alarm in Syscom sensor or in T4D web? So in this case, you can do both. If you want, you can also raise the alarm on the Syscom, but I think it's easier based on like what I present on the platform is maybe easier to do it on T4D. So you will have all the alarm on T4D, but it is also possible to do it through the Syscom device itself. Can I install SFTP server on the same version as T4D? Technically, it is possible to install SFTP server on the same server as T4D, but we won't recommend this because as for safety reason, for cybersecurity reason, we won't recommend, but it is possible. Can I integrate velocity in T4D to get displacements? So good question. To be honest, I think we didn't think about this before, but maybe this is something we can check with Bart to improve. I think it's a very interesting request, so we will think about it. Do you have any availability to measure vertical displacement within the accelerometer during the event? Good question for Bart. If we integrate, probably. I don't know. I'm not sure.
Yes, no, the idea, not at the moment, no. We'll rather calculate third octave analysis, for example, directly on the background mode, vibration dose values, RMS values, and this kind of calculations, but not really the displacement at the moment, no.
Okay. project. Very interesting. Thank you. So I think we pass all the question about the QA. So I think so you can if you are like a customer or dealer, you of course you can reach out to us to ask question, or if you want you can also reach out to your local dealer to ask question, but don't hesitate, or you can also visit our local distribution website to know who is the closest local distribution close to your place, where to buy. Geospatial.trimble.com, where to buy. We also have a YouTube channel. We work a lot with the monitoring team to improve, and we have a lot of video. Maybe I can present here, Trimble monitoring, and in this YouTube channel, you can have like a lot of different very helpful tutorial to explain how to set up a device, how to manage like geotech, how to manage vibration. I put it in a geotech, or also how to manage like a different sensor from Trimble Insight for Terra Insight, sorry, like piezometer, crack meter from RST. And we add like a special part for vibration. And if you select there, you will have your how to configure a SFTP server for vibration, and how to set up your vibration sensor. We also have a Trimble website, as I show you, and with this website you will be able to see the different solution Trimble monitoring can provide, and I recommend you visit. And you can also select on demo sites, and we recently add a new demo site, which is the demo site, my demo site here in Nantes, the one I show you today. And you will have also access to different website, different demo site, like a dam, and also a building, Trimble building in Westminster. So here's the demo site. Partner with Trimble is guaranteed success. So you can also go for live monitoring project, I think is what I mentioned on Trimble monitoring. And yeah, I think I present almost everything. So I don't know if Bart, you have something. Maybe you can add, we didn't add the slide, but maybe you can tell to the customer where they can go to reach out to Syscom.
Sure. So thanks, Ben. So first, you can really contact me per email or to info@syscom.ch, and we'll reply very quickly to your questions. And we have also a website. It's syscom.ch, and there you will see all the yes, thanks, Ben. Syscom.ch, and here you have a contact form. It will go directly to me, so don't hesitate really to go there, and I'll address whatever questions you have, and you will get an answer very quickly. So thanks again for your attention on that, and I think again it's a great thing to be able to work with Trimble and Ben, and we are looking forward to providing you vibration devices, vibration monitoring devices to your T4D projects. Thanks.
And thank you very much. Have a good day, and thanks for your attention.